Peak ground acceleration, PGA, is equal to the maximum ground acceleration that occurred during earthquake shaking at a location. PGA is equal to the amplitude of the largest absolute acceleration recorded on an accelerogram at a site during a particular earthquake. Earthquake shaking generally occurs in all three directions. Therefore, PGA is often split into the horizontal and vertical components. Horizontal PGAs are generally larger than those in the vertical direction, but this is not always true, especially close to large earthquakes. PGA is an important parameter, also known as an intensity measure, for earthquake engineering. The design basis earthquake ground motion, DBEGM, is often defined in terms of PGA. Unlike the Richter and moment magnitude scales, it is not a measure of the total energy, magnitude, or size of an earthquake, but rather of how hard the earth shakes at a given geographic point. The Mercalli intensity scale uses personal reports and observations to measure earthquake intensity, but PGA is measured by instruments, such as accelerographs. It can be correlated to macroseismic intensities on the Mercalli scale, but these correlations are associated with large uncertainty. See also seismic scale. The peak horizontal acceleration, PHA, is the most commonly used type of ground acceleration in engineering applications. It is often used within earthquake engineering, including seismic building codes, and it is commonly plotted on seismic hazard maps. In an earthquake, damage to buildings and infrastructure is related more closely to ground motion, of which PGA is a measure, rather than the magnitude of the earthquake itself. For moderate earthquakes, PGA is a reasonably good determinant of damage. In severe earthquakes, damage is more often correlated with peak ground velocity. Geophysics. Earthquake energy is dispersed in waves from the hypocenter, causing ground movement omnidirectionally but typically modeled horizontally, in two directions, and vertically. PGA records the acceleration rate of change of speed of these movements, while peak ground velocity is the greatest speed rate of movement reached by the ground, and peak displacement is the distance moved. These values vary in different earthquakes, and in differing sites within one earthquake event, depending on a number of factors. These include the length of the fault, magnitude, the depth of the quake, the distance from the epicenter, the duration, length of the shake cycle, and the geology of the ground. Subsurface. Shallow focused earthquakes generate stronger shaking acceleration than intermediate and deep quakes, since the energy is released closer to the surface. Peak ground acceleration can be expressed in g, the acceleration due to Earth's gravity, equivalent to g-force, as either a decimal or percentage, in meter per square second. 1 gram equals 9.81 meters per square second, or in gal, where 1 gal is equal to 0.01 meter per square second. 1 gram equals 981 gal. The ground type can significantly influence ground acceleration, so PGA values can display extreme variability over distances of a few kilometers, particularly with moderate to large earthquakes. The varying PGA results from an earthquake can be displayed on a shake map. Due to the complex conditions affecting PGA, earthquakes of similar magnitude can offer disparate results, with many moderate magnitude earthquakes generating significantly larger PGA values than larger magnitude quakes. During an earthquake, ground acceleration is measured in three directions: vertically, via UD, for up-down, and two perpendicular horizontal directions, H1 and H2, often north-south, NS, and east-west. EW. The peak acceleration in each of these directions is recorded, with the highest individual value often reported. Alternatively, a combined value for a given station can be noted. The peak horizontal ground acceleration, PHA or PGA, can be reached by selecting the higher individual recording, taking the mean of the two values, or calculating a vector sum of the two components. A three-component value can also be reached by taking the vertical component into consideration also. In seismic engineering, the effective peak acceleration, EPA, the maximum ground acceleration to which a building responds, is often used, which tends to be 2/3 to 3/4 the PGA. Seismic risk and engineering. Study of geographic areas combined with an assessment of historical earthquakes allows geologists to determine seismic risk and to create seismic hazard maps, which show the likely PGA values to be experienced in a region during an earthquake, with a probability of exceedance. Seismic engineers and government planning departments use these values to determine the appropriate earthquake loading for buildings in each zone, with key identified structures, such as hospitals, bridges, power plants, needing to survive the maximum considered earthquake. MCE. Damage to buildings is related to both peak ground velocity and PGA, and the duration of the earthquake. The longer high-level shaking persists, the greater the likelihood of damage. Comparison of instrumental and felt intensity. Peak ground acceleration provides a measurement of instrumental intensity, that is, ground shaking recorded by seismic instruments. Other intensity scales measure felt intensity, based on eyewitness reports, felt shaking, and observed damage. There is correlation between these scales, but not always absolute agreement, since experiences and damage can be affected by many other factors, including the quality of earthquake engineering. Generally speaking, 0.001 g, 0.01 meter per square second, perceptible by people, 0.02 g, 0.2 meters per square second, people lose their balance, 0.50 grams, very high. Well-designed buildings can survive if the duration is short. Correlation with the Mercalli Scale. The United States Geological Survey developed an instrumental intensity scale, which maps peak ground acceleration and peak ground velocity on an intensity scale similar to the felt Mercalli scale. These values are used to create shake maps by seismologists around the world. Other intensity scales. In the 7-class Japan Meteorological Agency Seismic Intensity Scale, the highest intensity, Shindo 7, covers accelerations greater than 4 meters per square second, 0.41 grams. PGA hazard risks worldwide. In India, areas with expected PGA values higher than 0.36 grams are classed as Zone 5, or Very High Damage Risk Zone. Notable earthquakes. See also, earthquake simulation. Japan Meteorological Agency Seismic Intensity Scale. Spectral acceleration. Bibliography. Murphy, J. R. O'Brien, 1977. The correlation of peak ground acceleration amplitude with seismic intensity and other physical parameters. Bulletin of the Seismological Society of America. 67. 3. 877-915. Campbell, K. W. 1997. Empirical near-source attenuation relationships for horizontal and vertical components of peak ground acceleration, peak ground velocity, and pseudo-absolute acceleration response spectra. Seismological Research Letters. 68. 154-179. DOI. 10.1785 GSSRL 68.1.154 Campbell, K. W. Y. Boswognia. 2003. Updated near-source ground motion. Attenuation. Relations for the horizontal and vertical components of peak ground acceleration and acceleration. Response spectra. Bulletin of the Seismological Society of America. 93. 1. 314-331. Bibcode. 2003 Busser. 93. 314c. DOI. 10.1785 0120020029. Wald. D. J. V. Quittoriano. T. H. Heaton. H. Kanamori. 1999. Relationships between peak ground acceleration, peak ground velocity, and modified Mercalli intensity in California. Earthquake spectra. 15. 3. 557. DOI. 10.1193 over 1.1586058.